the first example we did was a GCF, so you pull out the common factor. The second example we're going to do, this one right here, 16a squared minus 81. That is a difference of squares. 16a squared is a perfect square. 81 is a perfect square. A difference of squares factors to the square root plus the square root and the square root minus the square root. So this is for a minus 9 or plus 9. And then we switch the signs here. Any questions?
Nope.
All right. So when we have two terms, we are going to check and see, is it a difference of squares or could it be a sum and difference of cubes? Like this one. We'll call this example 3. This is a sum of cubes. And if we remember when we did cubes, the first thing we did is set up the signs. If it's a sum of cubes, it's plus, minus, plus. If it's a difference of cubes, what's the pattern of the signs? Minus, plus, plus. Okay? And then what we have to look at is, what was being cubed? Well, for this first one, A is being cubed. What is being cubed here? B. And then if you remember, we squared that first one, A squared. The product of the two, AB. And then squared the last one, B squared. So in this one, what is being cubed for the first term? What do we cube to get 27? 3. So this is 3x. What do we cube to get positive A? 2. So the signs, when it's a sum, are plus, minus, plus. So once we set up the signs, we don't change it. Now we square this first one. 3 squared. It's not a trick question. 3 times 3. 9. The product of the two. 3 times 2.
6.
Yes. We're on fire. And finally, 2 squared is 4.
Yeah.
Yep. And that's how you do that. Now, if it was minus, it's the same thing. Same process, except the signs change. Okay. So, those are our two choices when we have two terms. Let's, well, yeah, I guess GCF. Thank you. All right. GCF is always step 1. Whether we have 2 terms, 3 terms, 4 terms, we always look for GCF first. Now, this one right here. This is where we have 3 terms. These are all our 3 terms. But the leading coefficient is an understood 1. Now, this is where you ask yourself, what do you multiply to get negative 35 that you add to get positive 2? Now, some of you guys are creatures of habit, and you do not like doing these problems until you draw the X.
Yeah.
Okay? So what do we multiply to get negative 35 that we add to get positive 2?
I really don't know.
No, 7 and negative 5.
7 and negative 5. So it breaks up into x plus 7, x minus 5. Okay, so you try this one. This one right here. Try that one.
Okay, that's easy because there's no number in the front, but then when there's a number in the front, you have to do it.
I'm about to do that.
Okay.
I promise.
I remember, is there a shortcut?
Yeah, we're going to talk about it.
Because right now,
Try this one.
Which one? 4 or 6?
hey, so you try.
It's just x plus 4, x plus 5.
It's not your number 6. It's a number 6 that I made up. Yep, it factors to x plus 4 times x plus 5. What can you multiply to get 20 that you can add to get 9? Alright, now we're going to go over the last one, when a is not equal to 1. The first thing I'm going to show you is trial and error because it is the easiest way. Trial and error. So you try it, and you mess up, and then you try it again so you get it right. Alright, so here we go. 3x squared minus 4x minus 15. Now guys, we haven't given you anything that's really difficult. Difficult to
Bro, I can
factor.
do this.
So trial and error is always, should always be your first go-to method. Now, when I look at this problem, that is the only way I would do it, because my leading coefficient is 3. And if I'm multiplying integers, there's only one way to get it. 3 times 1. That's it. That's the only way to make 3. So Hayes, put your phone down and watch this, because this is like math magical.
Okay.
3 and 1. Got it?
How do you know?
3, because 3 times 1 is the only way to get 3.
Okay.
Okay, now our last number is 15. We have 2 ways to get 15. 1 and 15, and 3 and 5. Now, those of you that kind of like puzzles, this is like a puzzle. Okay, when we multiply, this term times this term gives us this. This times this gives us this number. Now, to get this middle number, it is this times this plus that times that. So what we have to do is kind of take these numbers and play with them. Do you see if I put a -3 right here, that makes this times that -9. And if I put a +5 right there, this times this makes a +5. What is -9 and +5?
4.
That's
Negative
right.
4.
-4. So that's called trial and error. So those of you that are pretty good with your multiplication, this is the way I would go. But if I stood up here and said, hey guys, what's 6 times 7? And that stumps you.
42.
If that stumps you, if you have to think about it for a second, then you'd want to
That
go
was
with
more
the
like
second
4
method.
seconds.
You want to go with the second method. And the second method is term splitting.
What about when the number's not 3?
I'm going to do one in a second that's not 3. Yeah. All right, now, this may have been the only way you were taught, unless you were my student and then you were taught this way first.
What about John Bowen?
He has his own factoring algorithm.
He does.
He does.
That's very real.
He's
All
like
right.
the Einstein of adolescent math teaching.
Willoughby prefers this method right here because it's kind of intuitive and it's the reason why we distribute.
What does intuitive mean?
Oh, yeah.
It means it just kind of makes sense to you. All right, term splitting. If you understand what's going on, it makes sense. But most of us just memorize a process. So, once again, if you're the 6 times 7 is I'm not sure kind of person, this is probably the method you want to go with every time. It works every time.
No matter what.
Okay? So term splitting goes like this. I'm moving that word because I need to do this times this. Do y'all remember when this was a number that was not 1? Maybe your teacher said to do this times this is -45. So then you would come over here and you would do the x, and that was -45, and this is -4. And we go, oh, -9, +5. And then what we did was we split, term splitting, this into -9 and +5.
Yeah.
Yeah, we remember this way.
Yeah, bro.
Okay. And then we would look at the first two and go, oh, the first two have a common factor of 3x. And that leaves x minus 3. So over here, we want to be left with x minus 3. So what would I factor out of the second pair of terms?
5.
+5. So we see both of these terms have an x minus 3 in common. We can pull it out in front, and then we group what's left. 3x plus 5. Well, the cool part is we got the answer right. Do you see that this matches this? The irritating part is this went straight from the problem to the answer, and this took a lot of work. if you are not good at multiplying, if finding factors are not easy for you, then you should probably do this method every time. If you're good with factors, then you should do that method every time. Much quicker. Alright, so Claire wanted one that didn't have 3 in it. This one right here. This is the one we're going to do. This leading number is not a 3. It's a 6. Well, that's a little frustrating because 6 has a couple factors. It could be 1 and 6 or 2 and 3. How do I know which one to start with? Well, let's look down here at this number. It is 5.
3, 2, and 3.
There is only one way to multiply and get 5. 1 and 5. So instead of starting with the first one this time, I'm going to start with the last. Now I'm multiplying to get a positive 5, but look right here. I added to get a negative 17. So if I'm multiplying to get a positive, but adding to get a negative, they both have to be negative. This was a quiz.
Bonus.
This was a quiz that I used to give in the quadratics unit. In the, where did I spell it wrong?
At the top.
I did, I left out the T. Thank you. Alright, so now this is where we have to play, and watch this. For some of you, it's gonna, like Hayes, I think Hayes will be really good at this. I think he's already gonna go, okay, if I put the 3 right there, that makes 15, and a 2 right there, that's 2 more, 17, I'm done.
Or you could just do the X thing.
You could.
That's easier.
Takes a
Wrong.
lot more days.
It's
Well, I
not.
Because I don't remember all the tricks and hints.
See, like,
These aren't tricks. This is like pure straight math.
Okay, but I don't know which adds to
old
what
Professor
and which
John Bowen beat the whole X thing in his mind, so I'll never lose that. It's like riding a bike.
Alright, I'm done. You pick your method. I will not harass you
What about when there's 4?
as long as your
Can we do
method
one like that?
leads you to the right answer. If there's 4, it's like starting with this step.
Oh, okay.
It's like somebody's already split that middle term for you.
Okay.
So it's like, hold on, can you go back to the one you just did with
Yeah.
the 6? So is it always going to be right, or is it only when there's like a number that you can multiply
Yeah,
in
that
front
way.
of the X squared?
You
Like
would
if
do
there was
this
like
method.
a,
You
if
would
there was
do
like a
this method.
7.
Like we could do it right here. It's 4.
But if it's a 7, you just do 1 times 7.
But the problem with this one is you could do 4 and 1, 2 and 2. You could do 1 and 9, 3 and 3. But I can already see it's 2 and 3 and 2 and 3. That makes -6, and -6 is -12.
So it doesn't matter.
It doesn't matter which method you use.
It doesn't matter what the
This is
variable is.
frustrating.
Doesn't either.
Alright, gotcha.
Alright, so, a couple choices.
I don't know if I want to.
Actually, only 2. You can either do your worksheet without listening to music, or you can put in your earbuds and listen to school-appropriate music while you complete your worksheet. Now, I'll be happy to help you if you get to any that stump you. My goal is for you to finish and not have homework, so you can go home and lay in your hammock, or go to practice,
And run till you.
Or the eye
Run,
doctor.
or work, or the eye doctor.
Or the eye doctor.
Okay.
You let your dog sleep
Or
on your
run 2
face.
miles.
Yeah.
10 minutes.